Good morning to everyone. This is batch 32 of EC department final year of Well-Tech Multitech Dr. Rangarajan Dr. Sagundala Engineering College, Chennai. We are done our final year project under the title of Design and Implementation of Renewable Energy Based Wireless Power Transfer System for Electric Vehicles. Our team consists of K.R. Tulasiraman, Sheikh Mohammad S. and V.Leeladharan B. In this video, let's see the execution of the project in detail.
This is our project objective. I am excited to share with you our objective of our project, which focused on the design and implementation of renewable energy basic wireless power transfer system of electrical vehicle. Developing a renewable energy generation system. Our first goal to harness clean energy resources such as solar, wind power to generate electricity to ensure that power used as wireless charge in both sustainable and environmental friendly. Using indicating coupling technology to aim to clear a wireless charge system of simultaneously transfer energy without a physical contact of technology. We improve a renewable for users, EV users. To ensure a stable, effective power delivery, we integrate the advanced power conditions of energy management circuit. This component will a regular energy flow and prevent functional improvement charging performance. Since the wireless energy transport involve electromagnetic field, we implement effective shield to minimize energy loss and exchanging a safety prevents of interface with another electronic devices.
This is our project existing system. I will be explaining the existing system or electric vehicle charging and battery swapping. In the current setup, the prototype system has been developed to charging an electric vehicle at the charge station. So the system uses a combination of computer vision and the wired communication to efficiently manage the charging process. So each station ability to identify the exact location of each battery module that needs to be swapped. So reducing the time and effort required compared to traditional manual swapping and wired charging. By validating the model, we can establish when and how the system can be optimized for the real world application, ensuring faster, more convenient and efficient charging for electric vehicles. So these results are analyzed and discussed. Such a validated model can be used to establish when it more convenient to use a structure rather than two separated devices. This is our project proposed system. In our proposed system, a renewable energy based wireless power transfer system for electric vehicles. As the demand for electric vehicles grows, there is an increasing need for efficient and sustainable charging solutions. So in our proposed system aims to address the integrated renewable energy source such as solar or wind power with wireless power transfer system technology and functionality. This combination not only reduce dependency on fossil fuels but also enhance the convenience of electric vehicle charging. So the system combines renewable energy source with wireless power transfer to enable sustainable electric charging, power condition and stabilize energy from renewable source to support reliable functionality. Wireless power transfer technologies. Inductive coupling allows wireless power transfer from a primary coil at the charging station to a secondary coil on the electric vehicle for efficient energy transfer. Electromagnetic shielding minimize interference and enhance safety during the power transfer process. And monitoring the control system optimize power delivery, coil alignment and safety features give.
This is our project of main block diagram. We have used two blocks, one transmitter block and receiver block. One transmitter used roadsides, and we have in that used in a solar panel to receive energy and store a battery and convert into AC to DC current and send throughout a transmitter to receiver coil energy and receive energy from the receiver coil, and we convert into a DC to AC current of with throughout a rectifier, and we have used in a 2 voltage sensor. In this our project, one was used for rectifier to show how much voltage we have converted into a AC to DC and another we used store energy, showing that the how much percentage of battery health, and we store a battery in a energy that supplies to a power supply unit that supply energy received from the Arduino 8238P. That another we have used in a LCD display to show the energy of charging or not charging, and a percentage of battery of charged. Of another we have DC motor.
So this is a full project auto setup. So this is the solar panel used in the transmitter setup. Connectors are connection with 12 volt battery with diode. So there is no reverse directional current flow. So that's why we are using diode in the 12 volt battery. And we are using inverter in between the transmitter coil and the battery. Why? Because the transmitter coil receives AC current, so that's we are using inverter in between the battery and the transmitter coil. So the same process. So this is the high frequency receiver coil, it receives AC current. So we are using rectifier. So in rectifier we are using transmitter coil, capacitor, voltage indication light and voltage regulator. Why? Because so when the receiver coil receives the AC current, the indication light will be indicated, and we are using 5 volt LCD display. So power more than 10 volt or 5 volt receiving in the receiver coil, so LCD display cannot be worked. So that's why we are using voltage regulator for LCD displays. So and the connections and the voltage regulator connected with power supply and the battery. This is the voltage for 12 volt battery
This paper is
in the receiver setup.
Of wireless charge of electrical vehicle and high efficiency wireless power transfer system,
and the connections are connected with the power supply of the receiver setup. So we are using 2 voltage sensors. One voltage sensors are connected with power supply with the 12 volt battery.
It is clear that the vehicle
and the power supply on the power supply connected with microcontroller, and one voltage sensors are connected with high frequency transmitter coil and the LCD display. So why we are using voltage sensor? One voltage sensor sends the battery current, one voltage sensor how much current receives from the receiver coil. So both we are note down the charging status in LCD display.
Wireless charge of EV can be both.
So that's why we are using voltage sensors and the battery 2 voltage sensors. So all these processes are controlled with Arduino microcontroller. So connected voltage sensors are connected with microcontroller. This is the DC motor of the receiver setup. So this is the final output of our project. So just first we start the receiver setup of the switch button. When wireless charging, the vehicle can be stopped. Now we can see the charging status in the LCD display. So this
is our project conclusion. This paper is represented as a review of wireless charge of electrical vehicle and high efficiency wireless power transfer system of our electrical vehicle charging application. Is proposed system and configuration and design consider we have analyzed and discussing in details. It is clear that the vehicle can electrification and analyzed because the environmental and energy related issues. Wireless charge will be provide many benefits as compared with a wired charge. A prototype or design built to test the popular renewable source of energy, solar energy. With the technology developing, wireless charge of EV can be both two functions. Students in controlling inverter design and human safety are still need to a near terms. This is our project, whole project. Thank you.